Once again, a warm welcome to everyone who has joined on this Saturday afternoon. This is not, a lengthy meetup. So we have planned this mini meetup for a quick, refresh. This is not a new topic or anything. Just sometimes, we tend to forget there are some concept available for us, to increase our performance of the Mule APIs. So this topic belongs to that area where we can, many of us might have used that cache scope and HTTP caching, but for many of us it will be a new topic to learn and to implement. So with that note, I will be starting this meetup, and again welcoming you all on this meetup. So moving to second slide. So this is organizer slide. So this is Akib, Javed and Abhishek. So I have total 8 years of experience. I'm working as a assistant consultant in TCS. So I'm a certified architect and a developer, and the relevant experience in Mule is around 4+ years. So Abhishek, you want to go?
Yeah, thank you. Cube. So, hello everyone. Hi, this is Abhishek. So, my surname is just shifted to Akib place. Okay, that's fine. So, I have overall of 7+ years of experience and 5+ years in Mulesoft. I'm a Mulesoft ambassador working as an associate solution architect in Epicero. I'm a leader for Guwahati and Lucknow Meetup. Uh, I write blogs, I create technical videos. I'm a certified developer and architect. So that's all from my end. Over to you, Akib again.
Yeah. Right. So reading the safe harbor statement. So both the speaker and the host organizing this meetup in individual capacity only, and we are not representing our companies here. And the presentation is strictly for learning purpose, and we as a host or presenter, we don't hold any responsibility that same solution will work for your business requirement, and this is not meant for any promotional activities also. So some housekeeping before we kickstart. So as Abhishek already mentioned, so we have started the recording, and this recording will be uploaded to the event page within 24 hours. And questions can be submitted at any time in chat, or if you have mic access, we can give, if you want to ask something about mic, we can give the access and we can make it more interactive. And as so feedbacks are very important to improve this whole program of meetups, online, virtual, or even if it is in person. So feedbacks are really important. It will help us to improve for the next meetups. Okay, so today's agenda, it is very plain and simple. So we have caching. What are its use cases? When to use? And what are the two prominent ways we can implement caching in our Mule APIs? So as we see on screen, there are two main ways how we can achieve the HTTP caching and cache scope. So we will discuss in depth for these two methods. Okay. So firstly, we have to understand what this term actually means and how it is relevant in terms of Mule APIs. Caching is not very specific to Mule APIs only. Caching is a very generalized term, and it is used everywhere in your whether it is a database caching or with in your laptops or computers, we have L3 cache or all those caches. So the meaning remains same, but in terms of Mule, when we say, so let us first go to the simple plain definition of caching, which is the storing of frequently used data in memory, file system or database, whatever at which level you want to do caching. If you want to do caching at database level, or if you want to do caching at the API level, we will see all these steps. So the basic definition is to store the frequently used data in the memory, file system or database, wherever you want to store. So, and when we say in computing world, in computer world, the cache is a high speed data storage, uh, which is for all your frequent data uses. And this, if you say caching in terms of strategy, so it is one of the design strategy also, when we are in a phase to improve the latency and performance of the API. So let's say an API is taking a longer time to respond, and which is causing delays and timeouts in the consuming the backend applications. So also there are certain SLAs. We whenever we work on certain APIs, we have some certain SLAs on which that API should respond. So caching will help you in minimizing those response times. Okay, and so many of the APIs, right, because there are many network hops. For example, the current project that I am working, right, there is a UI based on Angular, and then Angular, that UI calls Mule API, and from Mule API we do some transformations and call the backend API, and in backend API again it calls some other SAP system or Informatica or Salesforce. So there are many network hops. So for the user, and if user is on that screen and continuously refreshing the page or reloading the page again and again, so instead of going till the Salesforce layer, we can return the response from the cache from Mule layer itself. So you can imagine the time difference it will make. Okay, so cache help you in minimizing the response times to very quick and very fast. And caching can be very effective technique also, as I said, to improve the API response. But one important thing we have to take care, right? We have to implement cache in such a way, right? The stale responses are not being shown to the user. So we have implemented cache, but we have to make sure that is invalidated. When I say invalidated, it means we have to refresh the cache at a certain period of time, right? Otherwise, some older response or some stale data will be shown to the customer. So when we implement cache, we have to take some precautions also. We will see all the pros and cons later. Okay, so I think we have a very a general idea of what is caching. So any questions here? I will wait. If you have any question, when we should apply caching, what is caching, and why we even need caching. Okay, any questions here? I will wait, and then I will move to what type of data that requires caching.
No, I don't see any question.
Okay, okay, okay. So let's say when to cache. Okay, because whenever we apply something, a new flow or a new scope in your API, so we should always inquire some certain parameters, right? When to apply this caching and on what type of data we should apply this caching. Okay, so typically caching should be applied on these three types of data. Okay, the static data. Let's say we are using some low passing the key and we need to have the value of that. For example, let's say there is on UI we are showing some states data, or the, let's say when you are selecting US, then the states should come, or when you are selecting the country as India, then all these states values should populate. So this, when you pass India on the country drop, the selected values of it as the states of India should come in the next drop down. These are some static data, right? So for this, you need not to call the API every time to fetch those values. Okay, let's say you're fetching by passing IN to the database, you're fetching the data from the database. So every time you don't need to call these database call to fetch all the data from the database whenever you're passing India from the drop down. So these data, these are static lookups data where you are passing some key and you are getting the fixed values for those. Okay, so those type of data we can easily apply caching. Okay, and then we have the second set of data where it is updating on in 24 hours. Let's say 24 hours or 6 hours or 5 hours or 1 hours. There is a fixed time, right? You know that the time is 1 hour or 2 hours, and let's say you're fetching some data from the backend, and it gets updated every 5 hours or 4 hours. Then also you can apply the caching there. So even in that meantime, in that 4 hours, if someone is trying to fetch the data, let's say 100 times, so they don't need to call the database 100 times. Okay, Mule layer itself can cache the response and give you the data whatever number of times you need. And once those 4 hours are complete, so Mule will again call the database and cache the response, and then the new response will be sent across the new users, whatever new request is coming. And then we have fixed lifetime data. For example, some tokens which expires in 30 minutes, or let's say 1 hour. Some JWT token or some Octa token we have, which frequent, which have very fixed lifetime, and in 30 minutes or 1 hour they expire. So that all, this use case I think many of us have used when we use object store. So cache, when we say cache, it is internally using object store itself. So in Mule we have two different ways we will see, but whenever we say cache in Mule layer, it is done through object store only. Okay, so moving forward, so we have, as I said, right, we have two different types of. Let me open the, yeah. So I will just quickly open. Okay. So as we've seen that it is applicable for static data, and which have certain interval of change, and then we have some fixed lifetime of data. Okay, like example will be here Octa tokens. Okay, here some DB updates, and here some static lookups. Okay, and the major, I'm just summarizing so we remember for a longer period of time. So what issues caching fix? So caching fix mainly two issues: the latency, it increases, decreases the latency time and increases the performance of the API by making it responding quicker. So, and when we say caching, caching is done at two layers. We can have server side caching and we have client side. So in server side caching, we have the HTTP caching, and in client side we have that scope available, in under which we can directly use object store or we can use the cache scope. And under cache scope, default caching scope, or we can use one reference strategy. Okay, so we will see the two different prominent, these are the two different approach which we have seen, the HTTP caching and the cache scope. So today we will see HTTP caching and cache scope. So object store, when we use object store, this is also one type of caching only, where we store the Okta token or some token, and then we compare the value if it exists or not. Similarly, we can use cache swap also. We will see the implementation. Okay, and one thing that I have discussed already, we have to keep in mind, right? Uh, we have to refresh the cache at a certain period of time, so there is no stale data. Okay, stale data to the customer. So we have to refresh the cache. And how to refresh the cache? We can pass some headers, to invalidate the cache. When we say invalidate, it will clear the cache and call the backend API again to get the new response. Okay, so let us discuss about HTTP caching first. So HTTP caching, so we have seen, caching we can implement in two ways: the cache scope and the HTTP caching. So in HTTP caching, what it does, it cache the whole response. Okay, the whole API. This is your API. Everything will be cached, including the headers, response, attributes. Everything will be cached. And when we use cache scope, we cache only one particular connector response. Okay, let's say this is your listener. Okay, and then you are doing some transform. Okay, and then you are calling the database connector, and then you are doing some transform again. Okay, so when we use HTTP cache scope, then this whole API will be cached. Okay, and when we use cache scope, we can select which connector to. Let's say we only want to cache this DB. So every time the new DB call is not made to the DB connector, so we will add the cache scope here. Okay, so we have to understand the difference when to apply when which one. Okay, so if we are applying the HTTP caching, then it will cache the whole everything, whatever request is going on, the headers and the attributes, whatever, and this API will not itself be called. Okay, so this is your, let's say, UI. From UI you are calling the Mule API. Okay, and then you are calling the, let's say, some backend Salesforce system. So when we do HTTP caching, then this API will not be called and response will be given directly from here. And when you use cache scope, then UI will call the Mule API and it will execute this one, the transform one, and then the response will be given from here. So the Mule API will be triggered, and then response will be shared from the cache scope of this DB connector. Okay, so in this, when you use the HTTP caching, then you are skipping the whole API call. Okay, the response will be given from the cache itself without calling the actual API. But when we use cache scope, okay, the API will be called, okay, till where you have used the cache scope, and then from that cache it will return the response here and it will give it to UI. Okay, so your API will be triggered, so there will be a API call. Okay, in case of cache scope, there will be the API call, and in case of HTTP caching, this is out of the box policy. Okay, out of the box policy, given by Mulesoft. Okay, this is comes under quality of service. Okay, we will how we can apply this quality of service policy. This is out of the box policy, and which we will apply on any API. Okay, so this API call will itself will not made. So you will see a network hop being called less. Okay, but when we use this cache scope, the API will be called, all those transformation which we have done, it will be applied. Okay, and then the cache will be called, or whatever not related transformation, whatever steps you want to do. You there's, let's say, there are some loggers or some other things that you are doing in your API. So all those process will be triggered, and only this DB call will not be made. So the response will be given from the cache to the UI from listener. Okay. Any questions here? We will discuss HTTP caching again. I will show you the what are the limitations, and what are the pros and what are the cons, or what are the limitations basically when we use HTTP caching. Okay, so
One question, Akib,
yeah,
from
yeah.
Mohammed Shakir.
Uh-huh.
When to use object store and when to use caching?
Yeah, yeah, as I said, right, when we say caching internally uses object store only. Okay, as I said, when we use cache scope, right, when we use cache scope, it will give you option of default strategy. Okay, and it will give you a reference strategy. So when you use default strategy, it will use all the object store basic basic values. Okay, 10 days to live, 10 MB, and whatever TTL time to live is there. When we use reference strategy, then you can customize this object store variables. Okay, let me I think let me open the studio so it will be more clear. I will show you that where is the studio. So internally uses object store mechanism only to store the data, but it serves the purpose of giving back the request without calling the actual AP, whatever connector. This is cache is a scope. Okay, you can have multiple connectors in this scope. Okay, so let me show you one. Mm, okay, so let's say I don't want to call this every time. I want to cache the response. Okay, so wrap it in a cache scope. So when we do this cache scope, so you will see it says you can use the default caching strategy or use reference to a strategy. When you use default caching strategy, it is the using the internal object store all the basic values, whatever default values are for the object store. Okay, and when we go to use a reference strategy, then we have to create a strategy, and here again you can use the basic object store, or you can create your own object store reference. Okay, so to create the object store, we need to add the object store here. So then it will show you option to select the object store preferences. So we will come to this. Okay, so this is the cache scope which we can add. So now when the call comes and the cache is not expired, then it will not call the requester again. It will give the response from this cache only. Okay, and from where it will store in the object store itself. So when we say cache, it works on the function of object stores only. Okay, it internally uses object store mechanism to store the data and to fetch the data and to give you the response. Okay, okay, so I will delete this because I have to run this in my local. Delete. Okay, so as we are discussing this, right, this default strategy. So there are some cons of using this default strategy, because as we are this default strategy will be always in memory. Okay, so we know that object stores can be transient, or as well as persistent. So if you use the default strategy, then it will be transient and it will be in memory itself. when you use the default strategy. So that's why we have this option to use the reference strategy, where we can use persistent caching. And when we use persistent caching, then you have to configure the let's say DynamoDB or PostgreSQL, where you can store it, the persistent cache values. Let's say in this case what will happen, let's say your API is running and it gets restarted. Okay, so you will lose all your cache data. Okay, so if you don't want that to happen, then you have to use this reference strategy, and under that you have to use the persistent storage, where you can go for DynamoDB and PostgreSQL to store your uh, cache as persistent. So even your system restarts or the API restarts, your cache values will not be gone, and your API still can refer the values from that cache. Okay, and one more thing that we have to keep in mind when we apply caching, we have to make sure the payload which was coming into that cache scope is not streaming, right? We know we can have the streaming payloads also, right? When we implement streaming in our requester component or the database component, then we cannot cache that streaming component. Okay, so that data should be consumable means it can be cached at one go. When we use a streaming, the data comes into smaller bits, right? So this cannot be cached. Okay, that we have to make sure that we understand that the streaming data cannot be cached. Okay, so this we have to make sure. Okay, so what happens internally, right? Let me show you how cache stores the data. Okay, so there is one diagram that I will quickly show. Okay, when the cache scope start, right, we have seen the cache scope how to add. So we check whether it is a default expression or what, based. If it is a default expression, okay, then it will use some secure hash algorithms to generate the key for that. Okay, for that whatever value is coming. Okay, if you don't want default, then you have to pass your own some. If you're using a reference one, then it will evaluate your expression, and then it will generate the key based on your expression. But if it is default, it will use the its default key generation and generate the key, and then it will store that key, and then whenever the next request come, it will compare to that key. Okay, so on each request it will calculate the key using this SHA algorithm, and then it will store the response as the value. And whenever a new request come, it will check if the key is present in the cache or not. If the key is found, then it will return the response from the cache itself, right? So whatever this using this algorithm, it will generate the key, and whatever value of the payload is coming, it will store it as the value. And when the next request comes, okay, when the new request is coming, it will compare with the key, and if it is matches, then it will give the same response to this request. Okay, let's say new request is coming and it does not matches, then it will go and hit the backend service again. Okay, and it will store it again in this cache scope. Let's say same request is coming again, then again it will try to match the key. It will match now because it has stored it, so it will give the response again without calling the database or whatever the backend system we have. Okay, so if you are using this default strategy, right? So three things we have to know. Okay, everything will be cached in memory. First point. Second point will be it is a non-persistent, as I made said, right? Once the system restarted or API is restarted, everything will be cleared. And large payload is not suggested. Because whatever B core size we are giving, so it will start caching in the memory, and you will be getting this heap problem or the memory overload. Okay, out of memory issues, you will start getting those out of memory issues. Okay, so this is about the cache scope and the default caching strategy that is there. Okay, so let us see one quick example of this. Then we will see the HTTP caching example also. Okay, so I have made this quick application. Okay, if you see, this is the flow. Let me save it. Let me cancel it. Don't save. So if I pass the EID as 1 from the postman, it will call this flow reference. So this is implementation. So let's see what we are doing in implementations of flow. So we are just having one logger here, which is saying cache scope calling requester. This is the first logger, and then it will call this request, this API call. Okay, and then we have one logger, the cache scope completed. So it will call this implementation flow 1. So here what we are doing, we are waiting for some time of period. Let's say I'm waiting for 3 seconds to give the response back to my calling flow. Okay, this subflow will wait for 3 seconds, and then it will give the response to the main flow. So okay, so let's say when we do not have implemented caching, what will happen? Every time when someone call this flow, so it will wait for 3 seconds. Okay, and then it will give the response back every time, all for all the requests, right? But when we implement cache, what will happen? For the first time only, it will take 3 seconds, and then it will store the response. This response user, the value of this is Akib. So it will store the response in its cache, and next time it will take less than, the minimal time, whatever it takes. Let's say 100 millisecond or 200 millisecond, whatever time it takes. So it will not take the 3 seconds until the cache is cleared. Okay. Okay, so let me run this application. This is a simple application I have created just to save time. So if you see, this is the listener, nothing doing. We just call, this is the path of the listener, and in this there is one set payload where we are waiting it for 3 seconds. Okay, and then this is the logger that final requester. This is the last flow. So final requester is called. Okay, so simple. This is the API which is calling this flow, which is as another requester component to cache. You can cache it every anything else. Let's say we can cache this transform set payload component itself. But I wanted to show you because in the real world, we will be calling a new API, right, to cache. So that's why I have created as a new requester component. But you can, this is a cache scope, and you can add all the whatever flow you have in your. Just select that and right click, and just right click, and you will see the option to extract, wrap in cache scope. Okay, and you can do for multiple items. Okay, so let me run this. So, So I'm not explaining much about object store because it is already a known topic. So it will take another, if you want to explain everything about object store. So it uses object store, and everyone knows how object store works in Mule. So that's why I'm not focusing on object store things. Okay, so we have seen the implementation also. We are using the default caching strategy, and we are not changing anything. We just want to show some simple vanilla example. So we have not updated anything. When you click on this cache scope, we are using the default caching strategy and not referring to any other strategy. Okay, and we are not excluding any. We have not done any changes. It is just whatever it comes, it is as it is. Okay, so it is deployed. Yes. So let me open Postman. Okay, so this is the Cloud Hub URL. I have deployed it. Yeah, this one. So let us see the time. Okay, so I'm hitting it for the first time. So there is a 3 second of wait. So it is taking around for the first time because it is waiting for the more than 3 seconds, and then it is giving it the response for the first time. Okay, so let us see the loggers. Let me clear it. No, again taking it from the cache. So if you see the logger, it is saying cache scope requester called, then the final requester log called, and then the cache scope completed. All the three loggers are printing because this is the for the first time cache is empty. So this logger it is printed, this logger is, and this final logger is printed. All the three loggers are printed. Okay. Now it has generated the cache. Let me hit it again. You see the response time 525 millisecond. Hit it again, 26 millisecond, 26, 23, 24. Okay, it is not waiting for 3 seconds, right? So, and let us see the logger. Studio. Let me clear it and hit it again. See, 18 millisecond. And if you see the logger, it will be calling cache scope, calling requester, and cache scope completed. So this logger is not printed. HTTP logger. No, this one, last one, the final requester log. So because the call is not coming here, whatever response you are seeing, it is getting this response and printing this logger. Okay, so this subflow is not being called at all because we have cached the response and you are seeing the speed, right? Because in this set payload, we are forcefully asking it to wait for 3 seconds, and we have seen that when we hit it for the first time, it actually waited for 3 seconds, and then the response came in around 4 seconds, right? But now since we have the cache scope implemented, we have the this latency time and the response time is reduced to 18 milliseconds because the response, because now the call is not going at all to the, let me show it in in debug also so you can see it more clearly. Okay, so I will stop this. Maybe many of you have used already, so it will be little boring to you, but for I think many of us have not used. So I'm just explaining it more in a lower level so people can actually see it, and whenever you see a chance to implement it in your project, you can suggest this approach and then implement it if you have seen it already. Okay, you can explain it more clearly to the person who is asking why you need to implement this cache. Okay, so let me quickly run this in debug. So I've made a small application so you can deploy it faster and save our times. And as I have said, right, we are using default caching. So, and my payload is very small, right? So it is working very quick without giving any out of memory exception. But let's say if I started, giving it a payload of huge nested payload of JSON or XMLs. As I said, this is default caching, so everything will be in memory, right? Let's say I have deployed this on Cloud Hub on 0.1 vCore or 0.2 vCore and start giving it a 100 or something like those payloads, more than 100 KB, 200 KB, 500 KB, or 1 MB payload, and start caching it every time for the new request or some request, then our memory will start fail. So for that, if you see the payloads are huge, then you must use the reference strategy and go for persistent caching and store those cache in some DynamoDB or some other SQL system which you have configured. This is just an extreme example. For large payload, definitely you should not use the default caching mechanism because it is all in memory of your API. So your API performance will go, instead of increasing, it will go down because of low memory issues in case of large payloads. Okay, so I will add the logger here so we can see the log is coming or not. So I will add the debug here. Okay, and now we will hit it. It is for the first time. We have restarted our application. The cache is cleared. Okay, because it is not a persistent cache. We have restarted our API. So mm, this is our flow reference logger. This logger completed. It is going into the cache because there is no cache. We have restarted. So now it will wait for 3 seconds. Yeah, 3 seconds is completed. This logger and this logger is printed, and you will see the response. It takes, because it is in debug, so that's why you see more number of response time. Okay, so we see that debugger is coming here. Okay, and now for the second time when we hit, it is coming to the flow reference. Okay, call the cache scope, and the debugger is not called, right? Because it is taking the response from cache. Only first logger and the last logger will be printed, and this whole flow is not called because this whole flow is cached. Okay, so we will get the response. Okay, I think I have made it very layman terms how caching works. It is internally using object store. Whatever this response you see, it is stored internally in the object store itself with the basic strategy. Whatever basic default values of object store are there. Okay, if you want to customize it, then you have to use the reference strategy, and under that reference strategy you can update the time to leave and all those parameters. Okay, let's move. So I think we are clear with this cache scope. Any question, Abhishek, we have for cache scope?
No, 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 no questions.
Okay, okay, cool. So let me stop with this. Okay, so let me stop this. And I have added one more flow. So here we are not using the cache scope. So we will see how to implement HTTP caching on this flow. Okay, so this flow again, it's calling the implementations of flow, but we have not used the cache scope here because we will be applying this out of the box policy, the server side caching, which I have told you, right? This server side caching, uh, this one, right? This this out of the box policy. So it does not require any cache scope because we are doing this server side caching on those and on that endpoint. Okay, so two ways. First this way, this is the second way. And under this cache scope, we can use the default caching strategy, and we can use the reference strategy, under which we can customize the uh, all the object store values. Okay. Okay. So but when we use HTTP caching, so there are certain limitations, right? I have said, I will told you what are those certain limitations. So when I say HTTP caching, then it only works on GET and head endpoints. Okay, so these are the two endpoints on which only it will work. It will not work on post, put, delete, all those other. Okay, so it will not work. So this is the first, and the second one is 1 MB should be the size of the cache. It should not increase more than 1 MB. If you see the payload is greater than 1 MB, you should avoid using HTTP caching. Okay, and yeah, it is implemented at the API manager layer. Okay, so let us see, you know, how this policy work. So let's say this is your API gateway. Okay, and you have some policy here, let's say rate limiting or some other policy, and then you have the caching policy, and let's say you have some other policy. You have three policies implemented, and then this is your backend, and this is your UI or the front end. And as you saw, when you use caching policy, it uses the object store to store the key value pair using the SHA algorithm that we have seen, right? Whatever key comes in, it uses the SHA algorithm and saves the key, and the payload will be saved against that key. So let's say this is the key value pair of the object store. Okay, so let's say the first request come. Okay, it will try to check whether cache is there or not. If it is there, then it will respond, and this policy will not be called, and the response will go to UI. Okay, so this flow and this flow will not be called. Okay, if it found the cache. Okay, this is called cache hit. Means whatever key was coming, it is already present in the cache and it has responded back. So this policy B and the backend service call will not be made, and response will be sent to UI. Okay, so this is a cache hit. So when you apply caching, you have to make sure that you are getting maximum number of cache hit. Okay, so and then only it will make sense to apply caching. For example, let's say you have applied caching on a database, and it is rarely called. So the more number of cache hit you get, the more successful cache policy you have implemented, because you are skipping those network calls and those DB calls. But if that DB call is very rarely made, once in a day or twice in a day, then applying cache on that DB does not make sense. Okay, so the more number of requests are coming and the more number of cache hit you are getting, so it will be make your policy more successful. Let's say when we have a cache miss, so when it will be a cache miss, so from UI a request come to policy A, the policy A is implemented, then it will go to cache policy, then it will not found the cache, so it will call the policy B, and then it will call the backend, and then from backend it will be again stored into the cache, and then the response will go to the UI. So if you are making the whole circle till backend, then it is a cache miss. Okay, so you are calling all the hops and getting the value, and from the next time when the same request will come, then these two hops will not be called. Okay, so these are the two questions on cache miss and cache hit. Okay, so let us see how we can apply this. So this also makes you one point, right? So let's say you have a three policy you have implemented on one API, three policy on the API. So we have to make sure the caching policy is always at the last. Okay, because once it's a cache hit, then it will skip the policy. It will not call the policy B, right? So we have to ensure we have policy A, then policy B, and then cache policy. Okay, so both the policy are called, and then it will cache policy, this HTTP caching policy. Okay, and then it will either decide it has to go to backend or not. Okay, so that's why I have shown you a diagram like this, so you can understand. If you are adding cache policy on the second place, like in this example, then this policy will never be called because the response will be coming from here only. Okay, so you have to make sure whenever you are applying cache policy should be at the last. You have to reorder this in such a way that cache policy is always at the last. Otherwise, this policy B will never be called when there is a cache hit. Okay, and you will be missing out on those policy implementation. So you have to make sure about this. So this is also one very good example how to implement HTTP caching policy and when to apply that. And as I've already said, 1 MB of payload. Where is that? Yeah, 1 MB, the size of the payload, get and head. These two operations only, and it is it gives you that class loader isolation also, right? Because you are not touching the code of the API to implement caching. When you use cache scope, okay, then you are touching the code of your API. But when you're using this HTTP caching policy, you are using this class loader isolation where you're not touching your Mule code to apply the caching. Okay, so it is helpful in such scenarios, right? Let's say you have already implemented your API and it is in production and somewhere, right? And caching without touching the code, then you can go for HTTP caching. Okay, well, yeah, but you have to check for these three, these two, limitations. Okay, these are the two limitations you have to make sure without when you are applying the HTTP caching. Okay, and all these are very very good interview questions in terms of, let's say, how to increase the performance and decrease the latency of the API without changing any code in the API. This question you know is asked in many of the interviews. So this is one of the very good interview question. So the answer will be HTTP caching. So you can apply it on the API, and then you can decrease the latency of that API and increase the response time without even touching your Mule code. This is one very good question that always comes in the interview. Okay, so quickly I will show you that simple example of this. Let me. Any question, Abhishek? We have for HTTP caching, whatever I have.
No,
Uh,
no question till now.
okay, okay. So as I said, I have already deployed this application. So I will apply this HTTP caching. Okay. So, so if you see, okay. So when I will pass this EID is equal to 2, and it will call the HTTP subflow. And HTTP subflow, what it will do? It will call this implementation flow again. Okay. And it will wait for 5 seconds, and then it will give the response. So when we will apply caching, this HTTP caching, here we have not used cache scope. So caching will be done at server side. Okay, and then for the first time it will wait for 3 seconds, and for the next whenever we hit, okay, it will directly give the response without even calling this API. Okay. Okay. And for this we have to, whenever we have to apply, this is like other policy only, right? So you have to manage your API in the API manager. Okay, so all those steps I'm not going to explain. So I've already deployed this application, okay, in the runtime, and from API manager we have to apply the policy. So this step, I think we are all well aware of how to deploy the API in the runtime manager. Okay, because it is again a different topic, so there are multiple uh, sessions already available on YouTube and other meetup sessions. Okay, so quickly I will just go to settings. I have stopped this application. I will start. This is the same jar, the test caching which we are seeing it in our studio, test caching, and I will call this by passing the EID is equal to 2, and it will call the implementation subflow HTTP. So it is also doing nothing. So this is calling this implementation flow again. Okay, and in the meantime let me show you the policy. I will go to API manager. So this is the API. So the auto discovery is done. So you see this API is active. Go into the policies. So we see we have the quality of service. We go to add policy. Okay, go to quality of service. You will see HTTP caching. Okay, so let me show you the. So here everything I have kept it as default. So the cache entries, time to leave, all thing you can do, and we can make it as persistent or distributed in case you are using multiple worker deployment. Okay, since this is a trial account, so we cannot have this multi-worker deployment, and this is using follow HTTP caching directive. So you can pass the headers also to invalidate no cache and no store. Okay, we will see this in the postman itself when we call this. Okay, and this is by default get and head only, and it will cache. You can update all these based on your project requirement, which request or response you want to cache. Okay, and let's say you want to apply it on one certain method or all the resources, then you can do that. Let's say you have multiple get methods, so you can using the uh, regex, you can specify those methods. So similar to other API policy which we have implemented, same, only thing which we have updated here, we are trying to cache when the EID is 2. So when the EID is 2, it will come to this HTTP flow, and then it will call this request without the cache scope. So here EID1 is already having the cache scope, so that's why we are not caching it. So when the attribute will match the EID is equal to 2 from postman, then only it will cache it. Okay, so this caching key we have to update. So whether it is a query parameter or URI parameter or even the whole request path, you can mention it. Attribute dot request path. So whole path it will cache it. Whatever path you are passing in the postman, it will cache every time. But we have implemented EID is equal to 1, which is cache scope, which is working internally in the studio. And for EID is equal to 2, which is not using the cache scope. So we have to apply the HTTP cache, which is on the API manager. Let's check whether our API is deployed or not. Yeah, it is started. So let me go to the logs. Okay. Application is started 1337. Let me hit it. So get details is equal to 2. We are hitting it for the first time. So let us hit send. So you see it is giving response after waiting for 3 seconds in the application itself. So it is taking 2 seconds for the first time. Let us see the logs. So you see HTTP calling requester, final requester, and HTTP logger completed. All these 3 logs are coming. So this log is printed, HTTP calling requester, and then it comes here. It gives you this final requester, and then HTTP logger completed 1, 2, and 3. All the 3 logs are printed. Okay, and now so as we have implemented this, so from postman when you have to hit the caching policy, so you have to go to settings, and we have to you know remove this option send no cache header. What is happening from postman, we are sending this header. If you see the headers of postman, it is saying no cache. Okay, so even if we have implemented this caching policy, and when we are passing from postman this no cache, so it will not it will just discard the implementation of HTTP caching. Okay, so when in order to call this, we have to uh, turn off. Now when we hit it, you see the response, right? 298 milliseconds. It is not waiting for the 3 seconds, right? And if you see the logs 1339, we have hit it. There will be no log for 1339 because that API itself is not getting called. Okay, if you hit at multiple times, you will see no logs here for 1339 because that API itself is not getting called. You are getting the response from the API. The server side caching it is done, so you're getting the response even before your API is called. So your API is getting skipped because you have cached the whole API response, right? You see, and it is not waiting for the 3 second period. Okay, and let's say I'm sending it. I don't want cache. I will say no cache header. Send it. You see, it will wait for 3 seconds and then the response will come, and you will see the logs for 1340. Okay, any question? I think the most layman language I can explain both the caching I have tried. If any question, Abhishek, before I am done with my session. Let me see the slides also. I have not gone through the slides.
Yep.
Yeah, the cache scope we have already seen, the static data or the backend data. Okay, which type of data we should cache. Okay? Short living data or some complex business rules, right? Let's say you have in our current example we have seen, right, we are waiting for 5 second or 3 second. Let's say you have implemented some complex business rules which is taking, some ample amount of time, so you don't want that rule to run again and again, right? So you can use the cache scope and use that transformation under that cache scope. Okay, so whenever a new request is coming, it will not execute those complex business rule again and again, so it will save, for you. And this is http caching, right? So same request come, then it will not go back to the end system to retrieve the same information. It will give the response from caching itself. Okay. And as I said, there is limit of 1 MB, and it only works on get and head. And you can again make it persistent in the settings. Okay. And we can use the regex to apply it on a certain, specific examples resources. Okay. Uh, there is nothing else. This was a small topic to discuss. That's why a very quick closure of this matter. Abhishek, over to you.
Yeah, thank you, Akib. So if anyone have any question, they can ask.